wonderful introduction, Kishore. Good morning, ladies and gentlemen. Thank you so much for joining us here today. You could have been doing so many other things on a weekend, Saturday morning, going out to a movie or spending time with your family. You choose to attend this session shows that you are important and you are serious action takers, right? You care about learning new things, and we appreciate that. So let us dive into the session. First, let us understand the topic of the day. How to calculate the capacity for your next STP. This is the topic. So assumption is you're going to set up an STP tomorrow or day after or next month or next year or whichever. So either you are already in the sewage treatment business, STP business, or you are a user for STP treatment plant, sewage treatment plant. Somehow or the other, you are connected to sewage treatment. So you are here to learn how to calculate the capacity. First question, why should we learn to calculate? What is wrong? I mean, if we don't know, we have to learn. One of the major reasons why STPs fail is because either it is under capacity or it is over capacity. Both are a problem. Even under capacity is a problem because you would have a risk of flooding. You would have untreated water going out. And if you have over capacity, you're spending more on capital cost. You are not running the plant at optimal level. You're spending more energy unnecessarily. It is not just a question of capex, it's also the operating cost. So we need to arrive at the right capacity just to ensure that the treatment plant works the way we want it to work. Right. Now, let me start presenting my screen. Give me a minute, please. Firstly, am I audible clearly?
Yes, sir.
Yeah. Audible.
Okay, nice. Okay. Is the screen clearly visible to all of you?
Yes,
Sure?
yes, sir. Yes,
Yeah.
sir. Yes,
Fine.
sir.
Yes, visible.
Nice. Yeah, nice. Thanks again for that confirmation. Today you are joining this live webinar. I'm at Hyderabad in my office, and thank you for joining us again here today. So let's understand the cost of getting it wrong. What is wrong? What would go wrong if I undersize my STP or oversize? Like we discussed just now, one of the major reasons why STPs fail is sizing. A lot of times STP capacity is determined by some consultant, either an architect or a MEP consultant. Maybe they have applied a scientific principle behind that, or maybe they have not applied. Sometimes they don't even know. Some other project where they had done similar work might have had X capacity. So I assume X capacity is sufficient for us. It may not be the case because the reason why we set up an STP is compliance. We need to get permission from Pollution Control Board or local municipality or from both of them. If the capacity calculation is not correct, we may not get the approval. Okay, so this is number one reason why we need to get the capacity right. Okay. Just give me a second, please. I'll just see if I can mute all my hosts. All my guests. Okay, let me move forward. Okay, the capacity is wrong. You end up getting a lot of foul smell. You set up an under capacity STP, it has failed. Failed does not mean it is not treating water at all. Sometimes there is foul smell. Sometimes there is flooding in your apartment complex. Sometimes you get Pollution Control Board notices. And majority of the times, if the capacity is wrong, the costing is wrong. Either your capex or opex or both are on higher side. Right. And oversizing means basically wasted investment. All right. Now the agenda for us to discuss today is why, the why of correct sizing. The why we just now discussed, the how we are going to calculate the STP capacity based on which sector you are operating. You could be in residential sector, you could be in commercial sector, you could be in municipal sector, right? And from where, what are the authentic sources? Here, for us, it is not only important to get the capacity right, but also important to show the proof that we got it from authentic sources, especially when we file an application or give a presentation in local pollution control board. So the source is also equally important. So we have source called CPHEO, Central Public Health Engineering, Environmental Engineering Organization. And how are there any tools that can help us calculate this quickly instead of going through voluminous data, voluminous books from CPHO or CPHB or National Building Code? Is there some kind of tool? Yes, we have developed some tools which can help you, and we will show you where these tools are. And finally, we'll have your questions and answers. So 5 items that we are going to discuss today: the why, how, from where, and are there any tools, and finally, question and answers. So there is one universal formula for STP capacity calculation. The formula is very simple. How many people are going to use this STP, or how many people are going to use the project? Let us say it's an apartment project. How many people are going to use? If it is a hotel, hospital, if it is a school, college, how many people will be there in the project? And we talk about maximum capacity. Any infrastructure is designed for maximum capacity for which it is designed. If it is a hotel, let us say there are 100 rooms. You have to design the STP for 100 rooms. And maybe if there is some restaurant of, let us say, 50 people, you have to design it for 100 rooms plus 50 people. Okay. I request all the guests to please mute themselves and use other means of communication. Right? Thank you. Thank you so much. Okay. So always the number of people and per capita usage. Per capita means per person per day. Okay. That will give us a design flow. The per capita usage varies based on the kind of application. If it is a hotel, it is one. If it is a hospital, it is a different one. If it is a residential segment, it is different one. If it is a shopping mall, it is different. If it is an office complex, IT building, it is different. So we are going to dive deep and to understand, right, what is the capacity generation for each of these segments. Okay. Now, sewage generation is approximately 90% of water used, water demand, or water requirement, as we call it. So whenever a new project is planned, when I'm saying project, when I'm using the word called project, it could be a residential apartment complex or a hotel, hospital, or a commercial complex or an IT building. A detailed project report, DPR, is prepared by the consultants. It could be a MEP consultant, it could be simply an architect or project management consultant, whoever it is. The starting point is, along with the building, they prepare a water demand. That means how much of water is required for this project. Right. Water is required not only for flushing. Water is also required for HVAC, cooling towers, all these things. So a project report will make an estimate of what is the total water required for this project and what are the various applications. By thumb rule, as a thumb rule, it is assumed that 90% of this water will come out as sewage. If a project uses 100 KL of water per day, 90% of it, that is 90,000 liters per day, would come into the STP. That means you have to plan your STP for 90,000 liters. And how did this 100 KL arrive at? It is again based on the calculations that we are going to now get into. We are going to discuss that in depth now. Okay. Now, water consumption data. Who gives this water consumption data? What is the most authentic source? It basically comes from CPHEEO, Central Public Health and Environmental Engineering Organization. It is under Ministry of Urban Development. I'll show you the links in a while. It basically talks about per capita water demand in each different segment. If it is a college, how much a person would use. If it is a hostel, how much a student or a boarder would use. If it is a hotel, what will be the consumption? If it is a hospital, what would be the consumption? This kind of data is published by CPHEO, and we have to use this source because it is government approved. It is a government department which is saying we need to take this data, right? So they have published these manuals, about 10 different volumes of this manual, volume 1, volume 2, volume 3, like that, up to 10, 1 to 10 volumes they have published, right? This can be downloaded from this website, or it can also be downloaded from our modernstp.com website. You can look at this here. You can download from MOUD, Ministry of Urban Development, Government of India, gov.in. From this location also you can download, or from our website, modernstp.com also you can download. Now, these are the most authentic manuals as far as water and wastewater is concerned. So you look at any aspect of water or wastewater, they would have covered in these 10 chapters or 10 volumes. Okay, this is our most authentic source and most authoritative source. It is not just authentic, it is also authoritative source. So once it is shown to any regulatory department that the data is taken from CPHO manual, no questions can be asked. Even the Pollution Control Board people have to accept it at face value. All right. Now, what is CPHEO? Central Public Health and Environmental Engineering Organization. It is under the Ministry of Housing and Urban Affairs, Government of India. It is a most definitive national guideline. I am reiterating, it is a national guideline. This is the most authentic source for anything on water and wastewater. All right. Now, let us look at the information from this particular manual. This manual, chapter 3, that means volume 3, if you go to this particular page, table 3.4, is showing you the relevant data. Hospitals including laundry and beds exceeding 100 beds. That means any hospital with more than 100 beds or 100 rooms should consider 450 liters per bed. That means if the hospital has 100 beds, it is 450 multiplied by 100. That is 45,000 liters per day is the STP capacity. Okay. Whereas for smaller hospitals, less than 100 beds, they considered only 340. Why this difference? The difference is larger hospitals get more attendants along with the patients. They have more staff attending the patient and supposed to be more luxurious. Okay. So they typically use more water. And the larger hospital also generally maintains higher standard of cleanliness and hygiene. So they consume more water. This is the thought process. Now, hotels, you are seeing 180 liters per bed, right? But this is for a very small hotel. If it is a 3-star, 4-star, 5-star hotel, per room, you need to consider again 300 to 350 liters per day, per room per day. Hostels, they are talking about 135 liters. Schools, colleges, 135. Restaurants, based on the seating capacity, if it is a 50-seater restaurant, 50 into 75, 3,500 liters. And all possible scenarios they have considered here. Offices, how many users are there in an office? 45 liters per day per head, right? So I request all of you to download this book and keep it ready, especially the chapter 3 from CPHO manual. Now, this does not have certain amount of data. For example, if we are talking about an apartment complex, there is no mention about apartment complex here. How to calculate the number of people in an apartment complex? That part is not covered in CPHEO manual. So where do we get this data? So we have another authentic government resource for that. It is called National Building Code of India, NBC, right? This again, NBC can be downloaded from, you can just Google, find out and download NBC manual. We have not added it to our resources, but maybe by end of the day today, we'll ensure that this resource is also available to download from our website. All right. So what kind of information NBC provides? Let us go and look at it. If you just look at this part, extreme corner, 1 bedroom dwelling unit, that means 1 bedroom, 1 BHK flat is equivalent to 4 people, 4 population, right? 2 bedroom flat is equivalent to 5 people. 3 bedroom flat is equivalent to 6 people. 4 bedroom flat is equivalent to 7 people. This is a guideline by NBC. And if it is an office where you are not defining the number of people, 10 square meters is typically about 100 square feet. For each 100 square feet, 1 person equivalent. That means if you have an office of, let us say, 2000 square feet, it is equivalent to 20 square meters and 20 people. Schools and colleges, you have to add the strength of schools plus teaching and non-teaching staff. Likewise, NBC has given detailed description for targets or categories about which there is no information on CPHO manual. On the right side, this is another page I have extracted and put here. Factories with canteen, factories without canteen, right? Nursing homes, cinema halls, shopping malls, railway stations, airports. You're seeing shopping malls here, 25 liters per head per day. And where is this going to be used? 25 liters is for domestic usage. That means there could be some restaurants, etc., which are not shown separately in a shopping mall. So in a shopping mall, it is advised to take 45 liters per head. But how do you know how many people are going to come to your shopping mall? When you are preparing a project report, you expect that certain number of people are going to visit your shopping mall. That figure has to be taken here. There is no per square feet consideration in a shopping mall. All right. Let us just take up an example for a residential project. Okay, how do we calculate capacity in a residential project? Okay, in a residential project, we'll consider an example of the complex has 2 BHK flats, 50 members, 3 BHK flats, 80 members, and 4 BHK flats, 20 members. So let us start calculating the population in this project. So as per NBC code, right, 2 BHK is equal to 5 people, 3 BHK is equal to 6 people, and 4 BHK is equal to 7 people. So 50 multiplied by 5, because 50 flats of 2 BHK, then 80 multiplied by 6, then 20 multiplied by 7. 50 into 5, 16, 6 into 80, 7 into 20. That is 250 plus 480 plus 140. So total 870 is the population that is likely to reside in this apartment complex of 50 plus 80, 130 plus 20, 150 flats, 870 population. All right. Now, what would be the water requirement here? First, we are looking at a water requirement, water demand as we call it, right? So first we calculate water demand as per CPHO manual. It is 150 liters per person per day. So we have calculated the population as 870. 870 multiplied by 150 is giving us 1,30,500 liters per day. This is the water demand, out of which 80 to 90% is considered as sewage. 80% is a low estimate, 90% is a good estimate. But for capacity calculation, even 80% is considered good enough. So if I'm assuming 80% of this water is coming out as sewage, it becomes 100 KL, right? 104 KL to be precise, rounded off to 100 KL. Are you able to see the screen clearly? 104 KL, you can round it off to 100 KL. So from 130, we have gone to 100 KL. All right. So this is how we calculate the capacity, STP capacity in a given project. Now we have understood why we need to calculate the STP capacity. We have understood what is the source for information. We have also seen with an example how to do it. So we have covered the first 3 topics. Why, how, where. Now comes the question of, are there any free tools? We can also calculate in a similar manner for various other applications like commercial. You can say a shopping mall, an IT building. You just have to look at the data from there and do the reverse calculation yourself. And in any application to Pollution Control Board for consent for establishment, consent for operation, we need to share the data source, authentic data source as CPHEEO, so that those people don't question our formula. All right. Now moving forward, are there any free tools which are easy to use, available anywhere online? We have created a similar, simple, easy to use tool for you so that you don't have to open all these books, understand where the particular topic is lying, and you don't have to spend so much of time, simply speaking. We try to make your job a bit easier, only to help you out, right? Let us understand how this works. So you need to go to our website, modernstp.com. All right. Okay. I'm taking you to modernstp.com website. Are you able to see my screen, Kishore? Can I confirm?
Yes, sir. Yes, sir.
Modern STP website is visible here?
Not, it is visible, but
It's not fully loaded. Maybe I need
yeah.
to share the right page. Okay. Maybe I'll open it separately and then share it. All right. It is not loading properly. Probably it has got something to do with this. Okay, on our website, we have
Sir,
give me a second, please. Okay. Okay, I'll just see that this part is taken care of. Kishore, please take up with Kiran. He has been working on this a while ago. Just ask him to shape it up properly.
Yes, sir. Yeah, yeah.
Right. On our website, we have something called Knowledge Center. All right. This Knowledge Center, if you go and check, this yeah, we have a Knowledge Center here. On the Knowledge Center, Kishore, this Knowledge Center page is visible?
It's visible, sir. Yeah.
Okay. Now we have what is called new STP purchase tools and resources. In this, you have STP capacity calculator. You can just go here, click this link of download, and then you're here, STP capacity calculator, right? You just click here on the link, start your calculation. It will open one new page, right? You just need to give your inputs, and then it will ask you, I'm giving some dummy information. Kishore, is the screen visible?
It's visible, sir. But I think page is visible. Start your calculation is visible.
Okay, fine. It will ask you for some basic information so that please understand that calculated data will come to this email ID. The response will come to this email ID. So you need to give your correct email ID, right? It is already taken. So it is not accepting my email ID. Okay, right. Now click on the image above. I have clicked on the image. So now it is asking you few basic questions, like what is the type of your project? It is a residential project, you say residential project, and then go to the next screen. And how many 1 BHK flats are there? Let us say I have something like 10 1 BHK flats, right? And then I have 20 numbers of 2 BHK flats, maybe 30 numbers of 3 BHK flats, and maybe 20 numbers of 4 BHK flats, right? And yeah, again, just asking me for a name, Suresh, and email ID where the data would be showed, suresh@modernstp.com, right? And my contact number.
Yeah.
I just submit the data, right? You would have got this response. You would have got already an email. Check your email. You will receive an email with the calculated capacity shortly. This typically takes about 1 minute for the calculation. In a minute's time, we would have got this response. So the basic point is we have created a resource from where you can calculate the STP by giving few inputs. Now, apart from this, are there any other resources? If you can just look at our page of free resources. In this page, you also have, Kishore, everything is visible?
It's visible, sir.
Yeah.
Sir, Rajshekar, sir, can you just mute, sir? Mute yourself, please.
All right. Okay. So you also have other free resources. From here itself, you can download the CPHO manuals. Just a while before we were talking about CPHO manuals, you can download from our website. So you can download all the CPHO manuals just by clicking on these download links and giving some basic information, and you will get the input by, get the resource by email, right? Apart from this, you have other resources like how STPs work, what are the different technologies about our STPs, and you can also talk to our experts. Basically talk to me, talk to my team members, and it will take you to our calendar link where you can fix up some suitable time so that we connect and take this forward. Or you can also join, you can click here and join our weekly webinar so that you attend the questions in person, you attend the webinar in person, ask and clarify all your doubts. All right. So these are some of the resources. Apart from this, we have one more resource wherein you can look at our previous webinars. Our previous webinar recordings also will be available for you to watch. These are our previous webinars. How to choose the right STP, everything about SBR, how to select the right technology, various topics. Whenever we have a webinar, at the end of the day, by today evening, this webinar recording will be uploaded here, added to this page. So you don't miss out any resource we have explained in detail, and you can just come to this page and come and check out for yourself. Okay, now let's go back to our topic. All right. Okay, these are the various resources that we have. Again, I'm reiterating, expert consultation. We have already seen that. Download manual, CPHO manuals. We have already seen how to download from our resources page. Access various tools and resources, that is buyer's guide, etc., that you can download from here. And also register for next webinar and also watch previous webinar recordings. These are the free resources that we are providing to our guests so that they take a learned decision. They take informed decision. So you don't go blindly. We are here to guide you properly. This basically culminates our presentation, but now we are open for your questions. Your questions, please. I'll stop presenting. We'll move on to questions. So I'll make it again gallery so that we see all of us. All right. Your questions, please. I'm sure all of you have something or the other to talk about. You can just unmute yourself. In case any problem, please put it in the chat. If you find any difficulty in unmuting yourself, you can also use the chat facility here.
Sir, you can ask any questions related to STP, wherever you find any troubleshooting, anything related to STP.
Yeah, anything existing STP problems also you can ask, not necessarily about the capacity calculation.
Yes, sir. Thank you. Thank you very much for giving us the valuable information, which are going to be very helpful for our future project, which is are going to currently in progress. I would like to ask about that, because whenever we are getting some project, there are client who have already specified their STP, that water capacity value. So if we are going to into plan accordingly, is there any problem going to come? Like if you have some client who are they're asking 150 kLD STP. When we are calculating, it is going to be more.
Right.
How can you sort it out?
Sir, I have been, I have gone through what you are saying. अभी तो नहीं है, लेकिन बहुत साल पहले STP का बारे में इतना ज़्यादा जानकारी नहीं होता था. People were not so knowledgeable. So builders का कंसर्न यही था कि मैं छोटा STP लगाऊं परमिशन के लिए. I'll construct a small STP for getting approval. Anyway, I'm not going to use the STP. But builder is there only in the beginning, first 1 or 2 years. उसके बाद में ये हैंड ओवर होगा एसोसिएशन को. And our business is at stake by accepting a lower capacity. When we accept and say, okay, चलिए 100 की जगह में आपने 50 लगा दिया, ठीक है, मुझे कोई प्रॉब्लम नहीं है. But your name is there in your STP, or your company name, your contact details, it is there in the label. So whenever there is flooding, the association people will think about you. They'll call you. सर आपने क्या STP दिया, हमें यहाँ पे flooding हो रहा है. Right. One. Number two, bad name spreads faster than good name. Our business basically runs on referrals. एक अच्छा कस्टमर, satisfied कस्टमर को देख के दूसरे कस्टमर्स आते हैं. ये बिल्डर तो पिक्चर से चला जाता है. After 1 or 2 years, builder is out of the picture. The user is actually the association. Right?
Yes.
If it is a commercial project, उतना ज़्यादा problem नहीं है. But if it is a residential project, you need to be a lot more careful. Today, social media is there. Everything we talk about, every bad experience that people have, they are sharing on social media today. They will go and say, so and so person has given me STP. एक company मुझे STP दिया है, वो बराबर काम नहीं कर रहा है. They will only say fail. The failure का reason क्या है? आपके builder तो insist कर रहा था कि मुझे इतना ही capacity का चाहिए. आप नहीं दिए तो कोई दूसरा से vendor से लेंगे हमें. Right? So to the extent possible, we should not succumb. We should simply tell them कि, sir, if you do go for a smaller capacity, you don't get PCB permission.
Yeah.
That threat we have to use. Okay, Somesh ji messaged asking for, he wants to get familiar with basic terms like BOD, COD, TSS, inflow and outflow standards. So these standards, you're talking about standards. Am I correct?
Yes, yes.
Okay. So each state has different standards. Kerala has the most stringent standards as far as BOD is concerned. They are insisting on BOD less than 5. Karnataka has BOD less than 10. Andhra, Telangana and rest of the country has BOD less than 30. So what exactly is this BOD and COD? What comprises BOD? What comprises COD? If you just see, when we talk about sewage is 99.95% water, 0.05% impurity. What is this impurity? It was water. You wash your hands on in your wash basin. What got added to the process? You used a soap. You washed hands. That means you used some liquid detergent, liquid or solid or whatever. From the detergent, some chemical, along with that chemical, some fat. All soaps have what is called LAB. Linear alkyl benzene is the chemical. It's a hydrocarbon. You can call it a hydrocarbon. It has carbon and hydrogen. So it has hydrocarbon, and fat also is typically hydrocarbon. Anything that has got energy is a hydrocarbon. Soap typically is 70% fat. Any soap today, if we take, it is 70% fat and rest is a lab chemical. Now, the more fat you have, the more fat water is going to get into once you use it as for washing your hands, washing your clothes, washing your body or hair, shampoo, right? Now, what is that? If it is a chemical, now what is the process we are going to use for sewage treatment? We are simply using bacteria to take away what we have added in the process. BOD is biologically digestible content. That means any organic content that can be consumed by bacteria. Let us say you had coffee. You wash the coffee cup. In the coffee cup, there was a trace of milk, there was a trace of sugar, there is a trace of coffee powder, which went and joined the water. It has become a sewage. Now, this coffee powder is something that bacteria can digest. This milk is something that bacteria can eat and digest. If there is some sugar, 1 or 2 particles of sugar dissolved in that is something that bacteria can digest. But if we have used a soap to clean that cup, the soap is a chemical. It is fat plus lab. Fat can be digested by bacteria, whereas lab cannot be digested by bacteria. So things that cannot be digested by bacteria contribute to COD. Things that can be consumed by bacteria contribute to BOD. There is a ratio, BOD-COD ratio. That means if in domestic sewage we say BOD is 250 to 300, COD is 500 to 600. That means the BOD to COD ratio is 1:2. If the ratio is very high, 1:4 means if it is laundry wastewater, it is 1:4. Laundry wastewater typically has a lot more soap content. Car wash has a lot more soap content. This cannot be treated in a conventional STP or ETP using bacteria, right? So we are measuring, essentially what we are talking about, BOD and COD is a measure of how much of biologically digestible content is there, how much of non-degradable content is there. This is the measure. TSS is total suspended solids. Suspended solids again contribute by physical impurities like your food particles, basically food. Let us say you cooked rice, you wash the utensil. So some grains of rice would go into that. When it is in water during aeration, they become smaller particles and they start floating in water. You call them suspended particles. Inflow and outflow. Inflow is what is coming into your STP. Outflow is what is going after your treatment. But what are the standards? In any sewage treatment plant, we are typically talking about 7 different parameters. If it is drinking water, we talk about 11 parameters, 19 parameters, different standards. Drinking water standards are different. STP standards are different. In an STP, we measure suspended solids, TSS, oil and grease, pH, BOD, COD, ammonical nitrogen, sometimes phosphate, and microorganism like coliform bacteria. These are the things that measure the strength of wastewater. The bacteria or virus should be below detectable level, especially coliform should be below detectable level. And you are asking in which situations anaerobic, aerobic, and anoxic tank should be used. See, there cannot be, whenever you are talking about anaerobic, the whole sewage treatment takes place with bacteria. So there are different type of bacteria. What any living organism requires is, every living organism requires food and also oxygen. Food is coming from the sewage. Oxygen is what we are giving externally. A small quantity of oxygen is available from the atmosphere, but this is available to the top layers of water, maybe up to 1 meter depth of water. If we are taking a lake, top 1 meter has access to atmospheric oxygen. So as you go deeper, there is no possibility of oxygen being present there. So a different type of bacteria grows. We call it anaerobic bacteria. This anaerobic bacteria does not require external oxygen. It would probably take oxygen from water itself. Now, what is the difference? Why not use anaerobic bacteria? Every septic tank uses anaerobic bacteria. Anaerobic process has been there traditionally. It's a more popular method of sewage treatment compared to aerobic. Aerobic has been in use of late, only in the last 70-100 years. Anaerobic has been there for more time. Now, in anaerobic, you generate methane gas, hydrogen sulfide gas. These things both are, they are causing foul smell. They cause obnoxious smell. So for this reason, we try to avoid them. Especially in residential or where public are going to be there, we try to avoid anaerobic treatment. But what is the disadvantage of using aerobic treatment? In aerobic treatment, you need to give external air from a source like air blower. And air blowers consume a lot of energy. So any anaerobic process is energy free. Any aerobic process is energy intensive. Anoxic is again a slightly different version of aerobic. After aerobic, you stop aeration, it becomes anoxic. You are not aerating anymore. You just aerated and left it open. You switched off the blower. Typically, that is anoxic. So every treatment process today, if it uses aerobic, anaerobic, anoxic, it is called a hybrid process. Any aeration processes like MBBR, SBR, they are purely aerobic processes. Wherever we use MBR, membrane bioreactor, they also insist on adding anoxic tank. Anoxic will help removal of certain biological nutrients like ammonia, nitrogen. They are better removed in an anoxic process. Okay, so a combination of anaerobic, aerobic, and anoxic will give you lowest operating cost, better treated water quality. Any more questions, please? Your question is, how does treated water reuse affect the STP sizing? No, STP sizing has got nothing to do with where you are going to use the water. STP sizing is independent. STP sizing is based on your usage pattern, how you generate, how many people are going to use your STP, or how many people are there in the project. Whereas gardening and flushing typically uses only 30% to 35% of total sewage generated. The rest of the water is coming from your bathrooms, your kitchens, etc. 65%, let us say 2/3 comes from other uses. Your flushing, that is water commodes, generate only 1/3 of total wastewater. For ease of calculation, let us say there is a STP of 150 KL. Out of this 150 KL, 50 KL would have come from toilet flushing, remaining 100 KL would have come from showers, laundry, and kitchen. So if you are looking at reuse, you don't need 100% of water for reuse. It is not possible to reuse 100% water without using advanced technologies. Right? If you use advanced processes, you can reuse 100% of the water, but again, selectively. There are lots of variables, people should be ready. Not many of us are. We don't have that kind of water shortage in India, or especially in Hyderabad or places like Kerala. It is there in some pockets of Bangalore and Chennai, where there is acute water shortage. Then they can look at 100% reuse. Otherwise, I don't recommend 100% reuse STPs. They are more expensive to build. They are more expensive to operate. But it is cheaper than buying all the water. It is viable for commercial projects. Now in Hyderabad, we are executing one project in a 5-star hotel and IT building. There, 100% of the sewage is used. It is treated. Then it goes into ultrafiltration. From ultrafiltration, water goes into RO. RO treated water goes into flushing. RO reject goes for flushing. RO permeate goes into cooling tower. Right? So this is how they are reusing all the water. But that kind of a setup is required only where you have tremendous water shortage. If you are buying water, it is better to set up all this equipment. This kind of equipment is expensive to set up as well as to run. You need more qualified people. Yeah, more questions, please.
Yeah, Mr. Suresh, I
Yes,
have one
Mehtaji.
question.
Yeah, please.
Especially this is specific to Hyderabad and Telangana because you are from that area, So I believe what I'm told, and is it correct to assume that the cost of raw water varies from 150 to 200 rupees per meter cube? If you buy fresh water, if it is by coming by tankers, it's about 200 rupees per meter cube. And if it is source of fresh water, then it is minimum 150 rupees per meter cube. Is that correct?
Now, there are two sources for you. One is if you are buying from government. Government is selling, that is Hyderabad Metropolitan Water Supply and Sewerage Board. Their official price is 45 rupees per KL. Okay. If you're buying an external tanker, most of the time tanker means a tractor mounted tanker, ferries about 5 KL. This 5 KL, they charge 600 to 750 rupees, depending on the season. If it is rainy season, there is plenty of water, you get even for 500 rupees. That means per KL it is 100 rupees. If it is summer, peak summer, it can go up to 1000 rupees also, wherein the price is going up to 200 rupees per KL.
In general, so I have a follow-up question. In general, so residential and mostly this municipal supply would be in commercial residential areas, but in industrial areas, my assumption is it is exceeding, about 150 rupees per meter cube. And the reason why I'm asking this question is, many of the industry players have been asking us to, to see if there's a possibility to treat and reuse most of the water. And they want all the water back from a sewage, plant.
Okay.
Is that something that I can, say that it is a real situation in that belt, especially the industrial belt?
Not in my knowledge. See, my knowledge is especially in summer. The problem comes only in summer when both rivers. See, Hyderabad has the good fortune of getting water from both Krishna as well as Godavari rivers. They have got dedicated pipelines. But if there is no water in the reservoir, Nagarjunasagar reservoir or Godavari river, then there isn't much that government can do. So they'll regulate. Essentially, they cannot regulate the water supply that is going into residential setup. They will only regulate the water supply going into commercial segment. That means something like IT buildings. So these IT buildings have no option but to buy water at that time during summer. And industries, in my knowledge, are not much affected because ultimately the water supply board makes money only supplying water to commercial and industrial segment. Residential segment, it is most of the time free. It is virtually free. There is very little metering and people don't pay that also. So in my knowledge, there could be one or two very few industries which are using a lot of water and they don't have access to. And again, if you look at the scenario in Hyderabad, most industries have moved away from Hyderabad city. So wherever there are plenty of borewell water also might be available. What kind of industry? Let us say industries like textile and dairy use plenty of water. They would have their own borewells. And if they are in semi-urban areas or rural areas, again there the tanker price would be lower than Hyderabad market price. So I would say it's a business opportunity. A particular client might have a specific requirement. Why not pitch and see? We are all in the business. Somebody is calling us. We have to explore the possibility. Maybe you can just send them a questionnaire. What is your source of water and reuse pattern? How you would like to reuse? What are good tickets for reuse? See, every water need not be passed into RO. If the water goes into, let us say, cooling tower, there is a HVAC requirement. Or boiler feed, it doesn't have to go to RO. Even ultrafiltration is good enough. Or if the boiler is a high pressure boiler, then you have a case for RO. So just take a selective approach. It is not one solution fits all.
True. One more question, which is relevant here to this same topic. Is there a compliance, strict compliance and adherence that is expected of high-rise? Because I remember Maharashtra just passed a resolution saying every flat with more than so many has to compulsorily treat their sewage. Is that something that is prevalent in states like Andhra and Telangana, where every high rise after certain capacity or every commercial has to have this strict sewage treatment plant, and it has to work? Is there something like that has come up?
This was there previously. Previous thing was 50 units in Hyderabad, 50 apartments complex must have STP. And Karnataka, it was 20 units or above. But now across the country, I believe one standard. I have not been able to get an authentic source, but I heard from multiple people that whoever is generating more than 5 KL per day must set up some kind of treatment plant.
And
Sir, here I want to add up, sir. I've checked with Pollution Control Board, sir. In Hyderabad, above 50,000 liters, whoever disposing 50,000 liters, they have to have a STP. In Telangana, in Kerala specifically, when I met last time, they have said that 5,000 liters. If they are disposing 5,000, they have to STP for sure. So same with Maharashtra as well, but Maharashtra is not so stringent. They have just specifically on BOD. That's all. They have not instructed. But here it is.
Yeah, Kerala is basically a water country. There is water everywhere, and they want to protect their natural water. So it's always better to treat it to the highest possible level and then discharge into the environment. And I have few more questions here. Looking forward to hear more about peak flow factor calculation. See, peak flow factor calculation is again given in our CPHEEO manual also. But otherwise, as a thumb rule, what we do is we consider a peak flow factor of 3. How it works is, first we have arrived at a STP capacity. Let us say my STP capacity is 100 KL per day. I'm just taking it for ease of calculation. 100 KL per day, if I divide with 24 hours, it is something like 4,121 liters or 22 liters per hour. Okay. What is peak flow? Everybody is using the toilets, bathrooms, cook kitchens in the morning hour, laundry in the morning hour. If it is summer, 7 to 10. If it is winter, maybe 7 to 10. If it is summer, 6 to 9. So these 3 hours are considered peak hours. Okay, so these 3 hours are considered peak flow hours. During these peak flow hours, we are going to generate roughly 40% of our total STP capacity. For this reason only, we have a collection cum equalization tank. The meaning of the purpose of collection cum equalization tank is any biological treatment plant is not designed to feed water for 1 hour and stop the process for the next 2 hours. You have to keep giving food to bacteria on a continued sustainable manner. Bacteria is a unicell microorganism. There is only one cell. So it's very sensitive. If you increase the temperature by 1 degree, 50-60% of bacteria will die. If you reduce it by 1 degree, same thing happens. 50-60% of the bacteria will die. It's so sensitive. And 1 hour there is no food, 30-40% of the bacteria would die. Right. So we need to feed whatever is the available food to the bacteria on a sustainable manner. So talking about this peak flow factor, you might generate more sewage in the morning 3 hours, but you have to distribute this sewage in the 24 hours time. So the purpose of collection tank is to keep feeding sewage 24/7. That's why in any biological process, they say you require minimum 30% load to start the STP. Any more questions, please?
I also want to know about that for your future session, that FSTP.
Fecal sludge treatment plant.
Yeah, this is a more.
Okay. I have not dealt with any fecal sewage treatment plants or fecal sludge treatment plants, but there are multiple technologies. We wanted to get into that at some point of time, but we decided it still doesn't have that kind of market potential. Government went all out 5-6 years ago. They wanted to promote in public-private partnership. But whoever has set up these plants is not doing any great business. Basically, the fecal sludge treatment plant is supposed to get sewage through tankers from septic tanks. So septic tanks are supposed to discharge their sludge through a tanker into a common public utility like a fecal sludge treatment plant. So fecal sludge treatment plant again has a similar treatment plant, but the BOD COD values are much higher. Typically, the COD is around 5,000. The BOD could be around 3,000 to 3,500. So you need to plan for higher level of BOD COD. And again, this is not a continuous process. You don't know whether you are going to get your sludge tomorrow or not. So better go for something which is more of a batch process rather than a continuous process. In my knowledge, not many fecal sludge treatment plants are working properly. A lot of them have been set up, but I have not come across anything that is really successful. If you are keen on this topic, maybe one of these days we'll have a individual discussion on this.
Please note here, we have experimented all STP technologies. We are free to discuss anything. In person, we'll discuss about specific questions. Definitely, we would like to answer all the questions. Yeah, please, we'll connect separately.
Any more questions, please?
Suresh sir, I just have a question. The same question was asked by an executive engineer from CPWD.
Okay.
So I am just typing the question and the question is on your screen right now.
Okay. In cases where influent character fluctuates such as BOD COD variation by more than 30%, how do we design buffer capacity to maintain consistent treatment efficiency? Okay. Now, whenever we are talking about sewage, Mr. Somesh, please understand this. When we talk about sewage, the parameters cannot fluctuate wildly. If they are fluctuating, there could be only one reason. Some kind of industrial wastewater from another source is coming and joining this. By default, BOD cannot be more than 300, COD cannot be more than 600. if it is sewage. If something else gets added, this can go up, right? And if it is going up, that means there is a problem in the inlet. The inlet has to be checked up, because you can't design an STP based on some assumed figure. See, fluctuation means one day it can go down, one day it can go up. You can design something for plus or minus 10%. You cannot design something for 30% or more. And government departments have a tendency to ask. Then we will have to say, we need to sample and set up a ETP, effluent treatment plant. It will not be a STP.
Okay, sir. Got it.
Okay, sir. It technically becomes a, for example, if you are there in a hospital where there is, or hotel where there is a laundry requirement, large amount of soap water is coming, then there is a possibility for fluctuation. But in that case, it becomes effluent treatment plant, not sewage treatment plant. Sewage means the parameters are very clearly defined. BOD more than 300, source is different, not sewage.
Okay. Sir, what is meant by MLSS concentration?
MLSS is a abbreviation for mixed liquor suspended solids. Okay.
Oh.
What is this mixed liquor suspended solids? Once we are using the word called suspended solids. Now, all the bacteria present in the aeration tank is present in the form of, it is, bacteria is, like we discussed, it is a unicell organism. You can't see it with naked eye. You have to put it below a microscope and see it if you want to see it physically. So it is always sticking to some kind of physical substance, like physical impurities, like suspended solids. So bacteria is attaching to suspended solids and it is living there.
Okay.
Okay, so when you measure the amount of suspended solids present in your aeration tank, indirectly you are measuring the quantum of bacteria in your aeration tank. It's simply speaking a measure of bacteria in aeration tank. And typically it should be 30% of the volume. If you just take, let us say you take the aeration tank sample into a 1 liter transparent bottle, put it aside for 30 minutes. In 30 minutes, it will settle down. The solids will settle down to the bottom. The volume of these solids, are so-called sludge, should be 1/3 of the bottle volume.
Okay.
That means the system is working healthy. It has sufficient amount of bacteria to consume all your organic content. But you cannot have the same formula in a MBBR STP. In an MBBR STP, your bacteria is attached to the MBBR media. It may not be present on the MLSS.
Okay.
Okay. So
Yes.
MLSS is not always a measure of a bacteria content, but generally as a thumb rule, the higher the MLSS, the more the bacteria. More the bacteria, higher the efficiency.
Okay.
Okay, sir.
So, yeah.
More questions, please.
More 2 questions. We'll wind up in another 10 minutes.
Hello.
Please, sir.
Yeah. Sir, can you share what should be the standard operating cost for STP?
Operating cost for STP. What type of STP, sir? Operating cost is dependent on what technology you are using. Do you have something in mind? Like
see, there are two. I will share two bases. One should be for using the wastewater for gardening, and one for using it for domestic, using in washing areas like toilet flushing and all that.
Okay. Sir, your operating cost primarily comprises of manpower cost, chemicals cost, energy cost, and maintenance cost. That means maintenance means, some belt is worn out, some pump is burnt, motor is burnt, you're replacing all this. So when the plant is new, first 1 or 2 years, your operating cost is typically low. As the STP ages, the consumption of spare parts or the equipment failures become more frequent. Then your operating cost goes up. So we cannot have a standard thumb rule saying that, this will be my operating cost. The technology also plays a very important role. Instead of having 3 operators, if you can have just 1 operator, the operating cost will go down. Essentially, the manpower cost is a major cost. Today, if you look at a person, on an average, a person would cost us as a STP vendor minimum 20,000 rupees per month. And for each site, we need to have a supervisor visiting at least 1 day in a week, once or twice in a week. That is a cost. And that person is working in an office. There is a cost. Then there is billing. An accountant is working maybe 1 or 2 hours in a month for billing. There is payment follow-up. All this is a cost, hidden cost. So on an average, we charge anything from 25,000 to 40,000 per operator to the client as a operator and maintenance cost. Apart from this, there will be chemicals, there will be electricity, there will be equipment repair cost. So I cannot give you a particular thumb rule kind of thing.
The last 2 questions, please.
Mr. Shahid, if you have any particular case in mind, I request you to take up with Kishore. Kishore, please discuss with him and see if we can give him more detailed inputs.
Yes. Definitely.
Guys, any more questions?
No, sir.
Manjula madam, you are trying to ask question. Yeah, Someshji, please ask. Yeah.
No, sir, no more questions. And whatever the remaining few doubts I have, I'll personally discuss with you both.
Yeah, definitely.
You're most welcome. You're most welcome.
Manjula madam, you are trying to ask some questions. If anything is there, please ask. We'll take up last 1 question. Anyone, please.
Srivasaji, thank you for your compliment, sir. I hope all of us have learned something new. I have also learned something new from you, right? Every day it is a learning session. The more questions come, the more brainstorming, internal thought process happens. It's a never-ending thing. And at Indus Ecowater, we specialize in building plants that have low capex, low opex. First thing we look at is what is the client's requirement, why he's setting up an STP, and what is the purpose of treated water. How are we going to dispose the treated water? Our equation we start from the end. We begin with the end. The first question we ask is, why are we treating this water? How are we going to dispose the water? With these questions, what kind of equipment is required is answered mostly, right? So like somebody was asking, if you are going to use it only for gardening, we recommend a very basic STP without even further tertiary treatment. If you want to use it for flushing, we suggest a small capacity, 30% to 40% capacity flushing unit. That means if there is a 150 KL STP, we put a 50 KL tertiary treatment, advanced tertiary treatment to take care of your flushing requirement. If there is HVAC or cooling tower requirement, what is the requirement there, volume wise? What is the quality required? So how can we achieve that quality? With ultrafiltration, with RO. So with these things in mind, we go reverse and guide the client properly, right? I request all of you to follow the same template. Begin with the end. Do not begin with the capacity calculation. Start asking questions as to why you are treating this water, how you are going to dispose this water. That will answer what technology to be used, what would be the capex, opex. All these questions will be answered with this, right? Thank you so much for joining us here today. I assume we all had a wonderful session and